2. This is homework week 5, I think. Unit 2 problem set 2, that's what it is. Let's start. So the question 1, I mean 1, 2, 3, 4, 5, especially 1, 2, 3, and 4, they're more like definitions. The dash of a polynomial is the highest exponent of its variable. So when you talk about that, given any, I'm just gonna use a red pen actually, give me just a second. So given a polynomial, let's say x to the power of 4 plus x to the power of 5 plus 3x cubed plus 2x squared and so on. They're asking you, hey, given this polynomial, what does the highest exponent of its variable represent? So here, what would 5, because 5 is the highest exponent, right, in terms of x, what does it represent? Well, it represents degree. So the degree of a polynomial, a dash is a point on the graph where the function changes from increasing to decreasing. A good thing about English in mathematics is that you can actually visualize it and like make sense out of it. So let's create a graph. Let's just figure out what it is. Okay, your function is changing from increasing, so it must be increasing at first, and then out of some point it changes to decreasing, right? And the point where it starts to decrease, what is that point called? We talked about that here. It's called relative maximum. Relative maximum point. So whenever you talk about relative maximum, it's not saying it's the highest point. It's saying that, hey, if your graph is increasing and it starts to decrease, the point where it starts to decrease, that's a relative maximum, right? There is a point where it could be higher than this on the graph, right? But that's not what you're saying. Okay. Determine a polynomial that does not have a variable attached to it. So for example, let's say here there's a term that doesn't have any variable attached to it. This 5 doesn't have any x. What would you call that? Well, don't just make it up. We have a name for it. It's called constant. The term is called constant, and if it is in the standard form like this, it is also your y-intercept. Because if you plug in 0 for x, all the terms cancels out. You're only left with constant, which is your y-intercept. That's if it's in standard form. Standard form is this, right? It's terms that's separated by addition or subtraction, and there's like multiplication. Factored is multiplication, right? Cool. A dash is a point on the graph where the function changes from decreasing. Well, if it's increasing and then decreases, it's relative maximum. If it's decreasing and then increasing, so this point right here, what would you call that? Well, if this point is relative maximum, could you give a shovel? What would you call this? Relative minimum. Minimum. What is the degree, the constant term, the leading coefficient of the polynomial here? So given this polynomial, what is the degree? The degree is definition the highest exponent, which is 5. So the degree is 5. Leading coefficient is the term, is the coefficient that represents the highest exponent. So it's negative 5 here because that's a term that's connected with the degree. So it's negative 5. Had this been positive 3, then this should be positive 3, right? And then constant, by definition, is this constant that doesn't have any x. So it's negative 3. Moving on, we already got 3 minutes, so 5 questions are done. Find all the relative minimum, all the relative maximum. So this is quite easy. We got this. This is a maximum, which is 1, 5. This is a minimum, which is 3, 1, right? Maximum, minimum, relative, right? And so you can figure this 2 out. I'm going to move on just for the sake of time. If you need any help, just come to the office hours. Just for the sake of time, it's easy. You got this. So, question 7. Which of the following is a polynomial? Well, the thing about polynomial, and I guess its definition, is that all of its exponents for the x, they're gonna have to be whole numbers. So you can only have 0, 1, 2, 3 and so on for your exponents. You cannot have negative, you cannot have fraction. So take a look at this, a, b, c and d. Which of the following has does not have 0, 1, 2, 3, right, kind of thing. So this has 1/2, so this is not a polynomial. This has 2, 1 and 0, so this is a polynomial. Is this a polynomial? It has a 1, but it's in the denominator, so it becomes -1, so this is not a polynomial. This is -3, so not a polynomial. Which of the following is not a polynomial? Well, 4, 2, 0 works, 3, 1, 0 works, -1 doesn't work, so C is the answer. 2, 1, 0 works, so perfect. Polynomials are said to be closed under addition, subtraction, multiplication. What does that mean? When it says it's closed under addition, subtraction, and multiplication, it means that if you add, if you subtract, or if you multiply any polynomials, you will always have a polynomial out of it, right? Well, what do I mean by that? So take a look at this. I'm just giving you an example. X cubed plus 3x squared minus 2x plus 3. That's a polynomial. All exponents are 0, 1, 2, 3 and so on, right? Doesn't have any negative, doesn't have any fractions. X squared plus 2x plus 4. Another polynomial. If you add them, you will get x cubed plus 4x squared, and this -2x and positive 2x cancels out, you're left with plus 7. Is this a polynomial? It is a polynomial, right? So and same thing with subtraction, right? You subtract it, you get the same thing, you get a polynomial. But why does it work? What makes something not a polynomial? Well, I'll just write here. For both of this, it makes sense, okay? When you add or subtract, you're not changing the exponent, right? You're not changing exponents. That means if all of your exponents are going to have whole numbers, all of the addition or subtraction, if you do that, they should also have the same exponents, they should not change. So if you aren't changing exponents, you will never have negative slash fraction kind of thing exponents. And that's only if you're adding or subtracting, right? Because you're not changing that. So that makes sense. That's a reasonable justification that since you aren't changing exponents, you will never have negative slash fraction exponents, which makes sense. Because that's what we said disqualifies as a polynomial is if you have negative or fraction exponents, right? Multiplication is a different story. Because if you multiply, you can have, you're changing exponents, that's what I'm saying. You're changing exponents. For example, if you are given x squared as a thing plus x, let's say that, and you're multiplying that with another polynomial name as x to the power of 1. You're changing it because x cubed plus x squared, when you times it together, you get x cubed plus x squared. You're changing the exponent, but here's a question. We know that all of this, I mean it's not a question, it's a statement. All of the exponents, if it's already a polynomial, are only going to be 0, 1, 2, 3, 4, 5 and so on. They are going to be whole numbers. Well, when you multiply whole numbers like 0, 1, 2 and so on, you will only get whole numbers as answer. For example, 2 times 3 is 6, 4 times 3 is 12 and so on. And even if it's like 0, right? 0 times 3 is 0, which is still part of whole numbers, right? Cool. That's a good justification, I would say. Question 10. Write a polynomial that represents the difference in length between the first and second flower beds. So let's just say that you're subtracting second from first. You would do x squared plus 4x plus 2 minus 2x squared plus 3x plus 5. Make sure you use parentheses because if you're subtracting it, you're going to have to distribute the negative inside the parentheses. So you get x squared plus 4x plus 2 minus 2x squared minus 3x minus 5. X squared minus 2x squared is negative x squared. 4x minus 3x is positive x, and then 2 minus 5 is negative 3. Is this a polynomial? Yes, it is, and it's a proof that when you subtract two polynomials, you only get a polynomial out of it. And then if you're going to combine them, you're going to have to add, right? X squared plus 4x plus 2 plus 2x squared plus 3x plus 5. You see how I didn't add any parentheses here because I don't need to change it. X squared plus 2x squared is 3x squared, 4x plus 3x is 7x, 2 plus 5 is 7. That's it. And this is also a polynomial, right? Given the polynomial, write it in factored form and find all zeros of the polynomial. Question number 11. Well, to do that, you're going to have to set the equation equal to 0. Make sure it's equal to 0. How many terms are we beginning with? There's 4 terms on each side. It's easier for me to separate, group them. They both have an x squared in common. You're left with x minus 2. They both have a negative 4 in common. You're left with x minus 2. X minus 2, x minus 2 is common. You can factor it out. You're left with x squared minus 4. Oh, this is amazing. Okay, I'm glad I put this question up there. X squared minus 4, this is not your answer, guys. You're not done here, right? You could further simplify x squared minus 4. How? X squared minus 4 is basically difference of squares, right? So, let's just say I'm going to give you an example, okay? A squared minus b squared. If we were to factor that, you see how a squared here is x squared and b squared here is 4. This is basically a minus b, a plus b. All the powers of x must be reduced to 1, unless you cannot do that. If it's difference of squares, you can do that. What if had this been x squared plus 4? I would not have been able to do that, right? This would have been it. X minus 2, x squared plus 4 would have been my answer because it's a sum of squares, and there is no real factored form of that. There is a factored form for difference of squares, and it's a minus b, a plus b. So you do x minus 2. Here it's x squared minus 2 squared. 2 squared is 4. That's what makes a difference of squares, right? And it becomes a represents x, b represents 2. All you do is make it x minus 2, x plus 2. And those are your factored form. And when you find the x-intercepts, you set each one equal to 0. You set the first one equal to 0. So x equals 2, that's your x-intercepts. Get the second one equal to 0, x equals 2, that's the second intercept. And yes, they repeat, and there is a reason why they repeat. I mean, there's a specific thing that happens when your x-intercepts repeat. So make sure you write them out both the times if that happens, okay? X plus 2, that's an x, okay? Equals 0, x equals negative 2. So those are your x-intercepts. One thing to realize is that what's the degree here? What is the degree of this equation? It's 3. How many x-intercepts? 3 x-intercepts, right? Isn't that cool? They will always match. Alright, perfect. Moving on to the next one. We did this activity in class. You were given a piece of paper, you cut the corners, fold it, becomes your height. Length and width is your length and width, I guess. So for the volume, it's length times width times height, right? So length here, if you cut it and make it of cardboard, it's 36 minus 2x. That's your length of the card box, open box. Width is 28 minus 2x, and the height is x itself, right? Because that's what you cut the x, making it your height. Write the domain that makes sense for the context of the problem. Well, what doesn't make sense for length, width and height? Personally, length, width and height have to be greater than 0, because if it's not, you no longer have a box, right? You don't have a box anymore, right? So set each of this equal to 0, your length equal to 0, I mean not equal to, greater than 0. So set up an inequality, right? So you're going to do 36 minus 2x has to be greater than 0. You're going to add 2x, so 36 has to be greater than 2x. So x has to be not greater than, 18 is greater than x. So x has to be less than 18, for sure, right? That's what it's saying. X has to be less than 18. If I set x a height greater than 0, so I know that x has to be greater than 0. So the lowest value I can plug in has to be greater than 0, right? Now what is the highest value I have to plug in? That's where I'm going to use this two information. 28 minus 2x has to be greater than 0. 28 has to be greater than 0. Not 0. It has to be greater than 2x. right? And then 14 has to be greater than x. So which one, 14 or 18? If you use, let's say if you use 15, or let's say you use 18, right? That means that if you plug in 18 here, you're gonna get a negative number, which should not work. So pick the lower upper boundary for this case, because it makes sense, right? Think about it. If you say you can only plug in numbers that are between 0 and 14, it makes sense because all of them are going to be positive. If you say it's 0 is, x is 0 between 0 and 18, then your weights will be negative, which does not make sense, right? So yeah, find the value of x that gives the maximum volume. For that you use Desmos, and I've already graphed it, right? So if you, I'll show you as well. X times 28 minus 2x times 36 minus 2x, and when I graphed it, this is what it looks like. Let me focus up here first. We said x has to be between 0 and 14. Why did we say that? Because if you take a look here, between 0 and this one 14, 0 and 14, it's positive, volume is positive. But if you plug in between 14 and 18, it's going to be negative. You cannot do anything greater than 18 because you can't cut box, that's length of 18. So it's between 0 and 14, your graph is positive. After that becomes negative. So that's the only one makes sense. So between 0 and 40, I'm looking for value that has the highest relative maximum, right? So you're looking for a relative maximum. So I'm just gonna figure it out what it is by looking at the graph itself. Because when you talk about relative maximum, you're talking about basically that, right? You're talking about basically what is the highest volume of that cut. Oh my god, it's so bad. Okay, why is it so all the way up in the air? So that is the relative maximum. If I'm also gonna graph it just to show you, but I'm just gonna give you an exact point. It's 5.209. Let's say 5.2 just to be good. 5.2. Cool. So what do I mean by that, right? So I know your graph is at 0, it's 0, but if you're increasing about a 5.2, it's gonna come back down. So 5.2 has a relative maximum, and the volume is 2342, something like that. 5.2. Let's just say that. Cool. That's what it looks like, right? I know it looks like really weird, like something like this, like where it comes back or something, but these are all like doesn't make sense, right? Because the domain doesn't make sense. Only domain is between this is the only domain that makes sense. Cool. And then write it in standard form. All you do is distribute the x. Imagine there is a wall here. This becomes easy, right? This is an easy thing for you now. It's 28x minus 2x squared, and then you can FOIL this. I'm not going to do that for the sake of time. We're already at 18 minutes. You guys can FOIL it out. Okay, you got this. Moving on. Given the graph, write it in factored form. Well, the factored form represents the x-intercepts, right? So you change the sign kind of thing. So take a look here. Your x-intercepts are -1, 2, and 3. So your factor are going to be x plus 1. So -1 became positive 1. X minus 2, so positive 2 became -2, and then x minus 3 equals y, I guess. Yep, that's your factor form. And I guess you can think about it, right? You change the sign, became that. Yep. Okay. Write the following equation in factored form and find the roots. Well, this is 0 equals 3x squared minus 243. They both have a 3 in common. I can factor it out. You're left with x squared minus 81. This is in difference of squares, so it's x minus 9, x plus 9. So that's it. And then each factors are x minus 10, x plus 9. So intercepts is 9 and -9. And it makes sense because its degree is 2. You should have 2 x-intercepts. Cool. Or roots. Roots and x-intercepts are the same thing, right? This is, I will do diamond method, or whatever you call this. 20, -9. This is -4, -5. You get x squared minus 4x minus 5x plus 20. X is common, x minus 4. -5 is common, x minus 4. You get x minus 4. X minus 5. So your intercepts are 4 and 5, which also makes sense because the degree is 2. X squared minus 4x plus 4. You could, you guys can do diamond method here if you guys want, or you can even just do like this is x minus 2 squared. Remember that where you do divide by 2, perfect square kind of thing. 2x squared minus 11x plus 3, you gotta use, because 3 times 2 is 6, there is no way you can get negative 11. Use quadratic formula. A is 2, b is negative 11, c is 3. Formula is negative b plus minus root of b square minus 4ac all over 2a. Negative b becomes positive 11. Negative 11 squared is 121 minus 4 times 2 times 3 over 4. 11 plus or minus 121. 4 times 2 is 8. 8 times 3 is 24 over 4. 11 plus or minus 121 minus 24. Let me just do that. 121 minus 24. Let's see. 97, so it's 11 plus or minus root 97 over 4. And 97 is a prime number, so that will be your answer. Alright, 97 is a prime number. Let me see. I think so. I cannot think of a number that can be divisible by 97 unless it's 13. 97 is a prime number. Okay, cool. Alrighty, question number 15. Given the equation, which of the following represents it? Given the equation, which of the following graph represents it, and explain why each of them can or can't be your answer. Well, if this is your answer, right, it's negative, that means I know it's facing down. X-intercepts are 2 and 3, right? So this is facing up, can't be my answer. Facing up, not my answer. This is facing down, x-intercepts are 2 and 3. This can be my answer. Can be my answer. Facing down, and then x-intercepts make sense as well. They are 2 and 3. Cool. This is facing down, but the x-intercepts are negative 2, negative 3. So I mean negative 2, negative 3 doesn't make sense. X-intercepts are positive. Here they are negative. Does not make sense. Facing up does not make sense. Cool. Facing up doesn't make sense. Don't make sense. Alright, that's your homework. If you have any questions, please use my office hours. And I'll see you all, like whenever I see you all.